Question number 23 says, prove that the curves x equals y square and xy equal to k cut at right angles. Now, right angles is something which is explained, given as a hint and star mark in the NCERT textbooks as well. If a to a square is equal to 1. Now, what do you mean by right angles? It simply means that at the points of intersection, for example, if you have two curves intersecting at some point P, then the tangent to the first curve and the tangent to the second curve at the point P must be at right angles. That's the meaning of intersection at right angles, cut at right angles, right? These are also called orthogonal. Cutting at right angles will also be orthogonal curves. Although orthogonal is a much more wider definition, orthogonal has a much more wider definition which says that at all points of intersection, the angle should be 90 degree. Between the curves, at all points of intersection, the angle should be 90 degree. That's the idea behind orthogonality, right? If two curves intersect at more than one point, then at all points, the angle between the curves or the curve should cut at right angles for them to be orthogonal. That's the idea behind this. Now, let's approach this question and see where does that take us. Prove that the curves this x equals y square and xy is equal to k cut at right angles if 8k square is equal to 1. Okay, so we are interested in k is already used. Let's pick up some point of intersection. Let's say they intersect at some point alpha comma beta. If these two curves intersect at alpha comma beta, then we can simply say that we'll find a relation between alpha and beta easily. First of all, yes, let alpha comma beta is point of intersection. Okay, therefore beta square, that is y square, alpha will be equal to y square, right? X is alpha, y is beta square, y is beta, and the other thing is alpha beta, the product is equal to k. Those are two things that I know. This is first equation, this is the second equation. Okay, and we have to prove that these intersect at right angles. So for that we'll have to find the slope. That is the derivative at this point alpha comma beta. Differentiating the first one x is equal to y square will tell me differentiate with respect to x. This will tell me 1 equals 2y prime, which gives me y prime is equal to 1 upon 2y. Okay, and this further tells me y prime will be equal to this slope will be equal to 1 upon 2 beta. Okay, the other equation for the second equation B, you have xy is equal to k. Differentiate with respect to x. What do we do that? How do we do that? We simply say that x times derivative of y, which is y prime, plus y times derivative of x, which is 1, is equal to derivative of k, which is 0. This is what you get. This tells me y prime is equal to minus y over x. This tells me this. And on the basis of this, I can say that y prime at alpha comma beta will be equal to minus beta upon alpha. Okay, this is known. Now, if these two curves intersect at right angles, then this first slope, this second slope, the product m1 and m2 should be equal to minus 1. Yes. That is something which you should be aware of, which we are aware of, right? So therefore, m1, m2 is equal to minus 1 implies that 1 upon 2 beta times minus beta over alpha is equal to minus 1. Where does that take us? Minus gets cancelled, beta gets cancelled. 1 upon 2 alpha is equal to 1, or 2 alpha is equal to 1 is what I get. But is this the required condition? No, this is not the required condition. The required condition is in terms of k. Okay, if these curves intersect at right angle, then this, cut at right angles if this. Okay, so let's try to find alpha maybe in terms of k, and we'll be able to get the answer, right? So what do we have? We have alpha beta is equal to k, we have alpha is equal to beta square. What do we need to do? We need to eliminate beta and get a relation between alpha and k. With the help of that, I can get alpha in terms of k, right? Let's do that over here. What do we have? This is beta is equal to k upon alpha. Therefore, alpha is equal to beta, which is k square over alpha square, which tells me that, yes, beta is k upon alpha. So alpha will be equal to beta square, which is simply equal to k square upon alpha square. And this further tells me alpha power 3 will be equal to k square. Is that okay? Yes. This tells me alpha power 3 is equal to k square. Okay. And can we substitute alpha over there? Yes, we can substitute alpha over there easily. Next, how do we eliminate this alpha from these two equations? It's pretty simple, not a difficult thing to do. We have alpha cube is equal to k square, and on the basis of this, I can substitute it here. But first, let's cube this, right? 2 alpha whole cube will be equal to 8 alpha power 3, which is equal to 1 power 3, which is 1. What is alpha power 3? This is k square. So this tells me yes, 8k square will be equal to 1 when the curves intersect at right angles. This implies this. Therefore, yes, this implies this and this implies this. Both are correct, and that's a complete solution of this question over here. This is a required condition. Yes,